Okay, this is a video for my applied 30S students. We're going to go through the problem solving for obtuse triangles in section 4.4. And let's start with a kite problem. Kelly notices a kite is stuck at the top of a tree. Looking up, she sees the kite at an angle of elevation of 36 degrees. She decides to move 15 meters closer to the tree and now sees the kite with an angle of elevation of 46 degrees. Determine how high up the kite is above the ground. Draw a diagram. Oops. I'm having some technical problems here. All right. So let's make a diagram first of all. So we would like, Kelly notices a kite is stuck at the top of the tree. She looks up at an angle of elevation of 36 degrees. So here's my 36-degree angle. I maybe have exaggerated that. That's probably skinnier than 36 degrees, but close enough. And she's looking up to see a kite stuck in a tree. There. Why, thank you.
That is a beautiful pine tree.
That's very nice. And it grows, we'll assume it grows at a right angle to the ground. We also have to make the assumption that the ground is flat. Otherwise, we'd need more information. What does she do now? Now she walks 15 meters closer to the tree, and now she looks up to see the same point at a 46-degree angle. And do we see what we have for a situation here? All right.
Yeah.
We have angle side angle in this triangle. I'll highlight it here kind of in red. This red triangle is angle side. You're probably saying, well, wait a minute, you only have one angle. But I know this one. How do I know that one? It's supplementary to the 46. So I'm going to go 180 minus 46 is 134. So this is 134. Is there any other possible way this triangle could have been drawn? And the answer is no, because they gave us two angles. Remember, there's never ambiguity if they give you side angle side, side side side, or anything with two angles given. So this is the only possible diagram I could have, the only possible way to arrange this. I mean, I could have drawn it to the right instead of to the left, but it's still the same triangle. So this red triangle here, I'm going to start putting some letters on it. Let's call the first place she started as point A. Let's call this point point B, and let's call the kite point C. So I need to find this height here. I'll call it H if you like. So here, I'll make it this dark red line here. So H is what I'm looking for. How am I going to find it? Well, we're going to need SOHCAHTOA, but the problem is we don't have enough information for SOHCAHTOA. We have two different triangles that are right triangles. We have the one that goes from A to, I guess I'll call this G for ground. I have the one that goes from A to G to C. That's a right triangle. But I don't know any of the sides. I know this part of it is 15, but that's not the whole side. I know that I have triangle BGC, but I don't know any of the sides in that one. So what's the strategy here? There's more than one way to do this. What are you thinking? Okay, we could find angle C. What would it do for us, though? Would it help us? Even if I knew an angle up here, I can't solve for how high this tree is without another side. What are you thinking?
Well, I mean, I don't know where this would help at all, but you can also solve angle C by using the triangle rule, like 46 plus 90.
Yep. But again, I'm going to say the same thing I said to the last person. What does this do to help us? We need another side. How are we going to find it? What are you thinking? We can find side A to C. I'll highlight it. Because this triangle here, I can do sine law on. So that's what we're going to do. We're going to find side A to C using sine law. So, okay, now if I'm going to use sine law, I am gonna need angle C, so you were right about that. We do need angle C, but it's not directly gonna get us to this height. So I was messing with it. I didn't say it was wrong, I just said, so what is that gonna do for us? Okay, so we do need angle C, because that would give us an angle across from a side, and then we can use sine law. So we're gonna do 180 minus 134 plus 36. And that's going to be, let's see, that's 170. So that's 10 degrees. So angle C is 10 degrees. I'll do this over here. So I'm going to find side A to C, which is the same as the one in this big right triangle, which in this situation I'll call little b, because it's across from angle B. So B over the sine of B equals C over the sine of C. And then I'm going to say, again, I'll do two steps at once here. I'll go sine of, I'll move this up, and angle B is, what is angle B? Is the 134 times the sine of, times side C, which is 15, all over the sine of angle C, and angle C is the one I just found, 10 degrees. And there we go. So side B is, and we're going to punch buttons. It's a side, I don't have to hit inverse sine, right? Okay, calculator, there you are. Clear all that. So sine of 134, close bracket, times 15 divided by sine of 10. 62.13, or 62.14 if I round it. So 62.14 meters is how long it is from A to C. That is the hypotenuse of the triangle that goes from A to C to G. So if this is the hypotenuse of 62.14 and this angle here is 36, how do I find the height? If I'm back in right triangles, I'm back in SOHCAHTOA, which one is it? It's a sine. You could, can you use sine law? Yes, you can, but once you're in a right triangle, you should use SOHCAHTOA. Well, then try it, but remember what happens when you plug in the 90. What's the sine of 90? It's 1, so that term's just going to go away anyway, because dividing or multiplying by 1 doesn't change any numbers, right? So it'd still work, but it's more work than you need to do. You can go back to good old grade 10 SOHCAHTOA for the rest of this question, right? So the sine of 36 is my height over 62.14, and that's t for top, t for times, 62.14 times the sine of 36. And again, I don't have to repunch 62.14. It is the last thing my calculator remembers. So I can just take my answer times, actually if I just hit times, it knows that I wanted the answer. Sine of 36 equals. Well, because it was the last thing that was on my screen, so I just hit times.
It's not that. It's just like, how did you get like 62.14 for like the other triangle without the right angle?
Because we use sine law for the other one. Let me go back here for a sec. Let me just write the answer first.
Oh, because you don't need that triangle.
No, okay, yeah, you're seeing it now?
Yeah, I'm seeing
Okay,
it.
so 36 point, now does it say where to round to?
No.
Then we don't care. 36.5 meters up the tree. That's a tall tree. So there we go. Let me kind of shrink that so you can see the whole thing. There we go. So again, basically what we did was we used this triangle here to find the side from A to C, and then that side is in this triangle here, the big right triangle. Is that the only way to do that problem? Nope. Feel free to try it again if you want and see if you get the same answer. Hang on, I'm trying to make that go away. I could have found the side from B to C and then used the 46 in my SOHCAHTOA. That would have worked. It should get you the same answer. Do I care which way you do it? Nope. As long as it makes sense and you do it right. Question? Yep, that was actually exactly what I wanted to do. Okay, so now that you've seen me do one of them, you're going to try another one. You're going to try this example here, but be careful. I'm going to actually spoil this one for you a little bit. This one does have two answers. So I'll give you a minute to think about it. I'll pause the video. Work with a partner if you want. So try this one at home and see if you can figure out why this one has two answers. All right, we're back. People are having a hard time finding two diagrams here. All right, so here's the first thing I'm going to do. I'm going to say, all right, Martina's rope is 7.8 meters long and it has an angle of 36 degrees. So here's Martina. We'll say M for Martina. And Martina's rope makes a 36-degree angle with the balloon. So there's B for balloon. Now here's the thing. Carl's rope is shorter. So how do you know which way it goes? Does it say that they're on opposite sides of the balloon? No, it doesn't. So it's possible Carl's 5.9 meter rope is this way. Or how do you know that they're not both holding it from the same side? Oh, I didn't like that picture. I don't like that line. I'm going to do it again. So there's Martina at 36 degrees, 7.8. There's the balloon again. But this time, that 5.9 goes this way. How do you know that they're not both pulling from the same side of the balloon? So there's two answers. It doesn't say, right? It's not about what this question says, it's about what it doesn't say. It doesn't say that they are on opposite sides of the balloon. It just says that the angle between them, the balloon, and each other makes a triangle in the vertical plane. Well, that's a triangle in the vertical plane. That's it. So we got to solve them both. So our goal is to find side B in these two triangles. How are we going to do that? Question? There's one angle given is one reason that there's two triangles. The other one is, and this is important, that this side, this rope, is shorter than the other one. If Carl's rope had been longer than Martina's, there's no way they could have been on the same side, unless, of course, Carl was behind Martina somehow. But yeah. I guess it is possible that there is two answers, because it does say that, then the situation would have been this, 36 and that one, and then you'd have had to figure out that angle, right? So it is possible, I guess, that there's two answers, even if, yeah, because what the problem that gives us the two triangles is that we don't know if they're on the same side of the balloon or opposite sides. So if they're on opposite sides, that's the triangle we're going to solve first. So how do I figure out what I want, which is side B? Well, I can only find side B if I know angle B, and I can only find angle B if I find angle C. So I'm going to find angle C first. This is going to be sine law. So angle C, so sine of C over C is equal to the sine of B over B. So the sine of angle C is, so I'll move the C up, and C is 7.8, times the sine of angle, oh wait a minute, sorry. This is not right. That's the next step. We need M first. There we go. So sine of angle M, which is 36, sine of 36. So the C moves up and becomes a numerator, and then we're dividing by side M, which is 5.9. And so the sine of angle C, actually I'll just go to angle C. I'll do this calculation in one step here. Okay, come on calculator. All right, now you're in the way. And there we go, clear. So 7.8 times the sine of 36, close my bracket, divide by 5.9 equals 0.777, inverse sine that answer. And I have 50.99 for the angle. So that's angle C. I won't bother rounding till I'm done. So angle B is equal to 180 minus 36 plus the one I just found. So let's see if we can find that. Calculator, come back. Calculator, come back. Oh, there we go. Okay, that's out of the way. 180 minus, open a bracket, 36 plus that last answer I just had. And that's 93.01. Okay, now that I know angle B, I can find side B. So B over the sine of B,
We need to know the distance between them.
because that's what we want. Yeah, we want to know the distance between them. B over sine B is equal to M over sine M. Might as well stick to the two that I knew from the start. So B is equal to the sine of that angle I just found times side M, which is 5.9, divided by the sine of 36. So side B is, so sine of the answer I just found times 5.9 divided by the sine of 36 is 10.02. So they are either 10.02 meters apart, or, okay, so now how do I go from this information to that? The calculator didn't say, oh, hang on, I'll calculate the other triangle for you. You have to figure out that for yourself. Where does it come from? Well, if this angle here was 50.99, then this angle here, which I guess I should call C primed, and I should call this one B primed. This angle here called C primed, let me highlight it for you. That angle and that angle are supplements to each other. They have to add up to 180. So, go back to this calculation here. Angle C primed is 180 minus 50.99. And I kind of want all the decimals again. I'm like that. I like knowing where all the decimals are.
How could they be congruent?
They're not congruent, they're supplementary. They add up to 180. How can that be?
No, how could C prime also be 50.99?
It's not. C primed is the supplement of this. If you put these two triangles together, here's what it looks like if you put, here's what it looks like if you put one triangle on top of the other. Right? You have the triangle we figured out, which is there,
Okay.
and then here's the skinny one. And see this angle and this angle are the same. So this angle is supplementary to that angle. That's the trick. Okay? So moving on. I kind of want that 50.99 back, so I'm going to go back, and I might even just repunch that real quick. If I can get the calculator to work. There we go. Okay, can we move over there, calculator? Come on, don't be shy. There we go. Oh, no, it's being shy. No, it doesn't want to move out of my way. No, okay, fine. All right, so I will, actually, I have an idea. If I make it smaller, that'll work. No, that doesn't work. There we go. Okay, so clear. So I'm going to take 7.8 times the sine of 36, close bracket, divided by 5.9 equals, and there it is, inverse sine my answer, boom, 50.99. There. So 180 minus that answer is 129.01. And then I'm going to use that angle C to find angle B. Again, I'll call it primed because it's the other version of this. So 180 minus the 36 that angle A is, or angle M I should say, plus 129.01. So back to the calculator. And now you can move over to that side if you like. 180 minus, open a bracket, 36, plus the angle I just figured out, answer. It's 14.99. And now I can solve for the other version of B, which I'll call B primed. I'm kind of running out of room a little bit here. Notice M isn't any different in this example, so sine of B, that's the sine of the 14.99 I just found, times side M, which is 5.9, all over the sine of 36. And my other B answer, we'll call it B primed, is, button punch time, sine of my answer, close my brackets, times 5.9. What am I expecting before I get to my final button punch? I'm expecting a smaller number, right? It's going to be that they're much closer together because they're on the same side of the balloon now, right? So let's see if that's what happens. Yep, 2.59, or I guess that'd be 2.60 meters. So I would then, if I had the room, for sure, I would make a conclusion Therefore, Martina and Carl
Or either.
are either, what was the first answer? 10.02 meters apart, or 2.60 meters apart. And basically, the difference between the two answers is either you have a balloon. Oh man, that's supposed to be a balloon. Like a Remax balloon. There you go, Remax. And they have a balloon. I know that this is more like a balloon like you send people into space, not weather equipment. But either Martina is holding her rope here. This is Martina holding her rope. And Carl is holding his rope over here. Or Carl is on this side. And it didn't tell us. It didn't tell us which, so we don't know. But there's the two answers. Either they're 10.2 meters apart, or if Carl is on this side, they are 2.6 meters apart. Question? Yeah, because you're supposed to solve the problem, and the problem has two answers. You don't get to decide which one you like better. The question that I just got, people at home probably can't hear that from there, is could we have a question like this on the test, and how about I'll say I guarantee it. Okay, so that's it for today. Yeah, that's got them groaning. So that's it for this video. Thanks for watching.